Hello everyone, welcome to Microchip Mini's How-To edition. I am Mamun Ahmed, 8-bit Marketing Applications Engineer at Microchip Technology. If you're watching this how-to video, I assume you already know how to set up a project in MPLAB X IDE. If you don't, please click in this link below to watch introductory Microchip videos to get started. Today, I'm going to show you guys how to make a motion sensor LED light without writing any code. For our project, we are going to use Microchip's low-cost 8-bit Curiosity development board with a PIC16 F1619 microcontroller, a MikroElektronika motion sensor click board, one MikroElektronika relay click, a 25-volt high-power Cree LED, a DC power supply for the LED, and some jumper wires. When we are finished with the project, we will have a fully functional motion-controlled LED light which can be used for rooms, hallways, or outside of your home. There are many different ways to complete this project. The PIC16 F1619 microcontroller features both configurable logic cell and hardware limit timer. Using these two peripherals, we can build this project without writing any code. Since these peripherals are core independent and all system functions take place in hardware, this application does not use any CPU bandwidth, so the CPU can be used to perform other operations to expand this project. For example, in a hallway light application, we can log data on how many times there was a motion, what time of the day the motion sensor turns on, and maybe even send this data over to the internet to a server for an IoT application. The possibilities are endless. So without further ado, let's get started. When we connect the motion click to the Curiosity board, the signal out pin is routed to port RA2 on the microcontroller, and port RA2 is also connected to the onboard LED D6. Right now, the motion click sends an interrupt signal and keeps the LED on for a few seconds if it senses a motion. Now, using this interrupt signal, we are going to program the microcontroller such way that it turns a high power LED on and keeps it on as long as there is motion. If there is no motion detected, it will turn the LED off after 30 seconds. I am using MPLAB X IDE 3.10 and MPLAB Code Configurator 2.25. If you're using a different version, the interface may look different, but the main idea will still be same. I already have a project created and named it as Motion Light. Now let's open up MPLAB Code Configurator from Tools, Embedded, MPLAB Code Configurator. Click on System and enable low voltage programming from Config 2 since we are using Curiosity board. We are going to use internal oscillator and select a 31 kHz low frequency clock so we can get a longer period for the timer. First, we are going to add a configurable logic cell by double-clicking the CLC module, so we can route the interrupt signal through a timer without an external jumper wire. From the pin manager window, let's click on RA2 as CLC in 0, since this is our interrupt pin from the motion click. Connect the line from the input to the OR gate by simply clicking the line. As the signal goes through an AND gate, we are going to make the other input high by inverting the second OR gate's output. Now we have the CLC1 out signal, which can be routed through different timers and peripherals. Next, we are going to add a timer. Let's select timer 2 for its special feature called hardware limit timer, where we can use the CLC signal as a reset source. You can visit microchip.com/HLT if you want to know more about hardware limit timer. To set up this timer, we will use f_4 as a clock source. To get a longer period, let's change the post scalar to 1 to 8 and pre-scalar to 1 to 128. Now if for some reason the period boundary does not update, we will change the clock source and then change it back to f_4 to see the correct boundary. We are going to type 30 space S as 30 seconds and hit enter on the timer period box, and it will round it to the closest value, which is 29.993 seconds, and automatically update the period hex value. Now we are going to use the CLC1 out as external reset source, use control mode as rollover pulse, and we want to reset the timer when timer to external reset source is equal to 1. Let's also enable the pre-scalar output sync and clock sync. Now, to drive a pin using the timer, we are going to add another CLC with a D-flop configuration. Here for the clock input, we are going to use CLC1 output LC1 out, and as a reset signal, we are going to use timer 2 post-scaled out. Make sure to connect these inputs to the associated gates. Also, we are going to set D high by simply inverting the second OR gate's output. Now we select RC5 from the pin manager as CLC2 out. Click on Generate Code, and MCC asks if we want a main.c file. Click Yes. Then click on Make and Program Device icon to program the curiosity, and we are done. At this point, the program is functional on the curiosity board. I chose RC5 as an output pin because it is also connected to an onboard LED D7. So it is easier to troubleshoot if something does not work. If the onboard LED works, but the external LED does not, that means our program is fine. We need to look at the external circuit. For the relay click, we are going to connect the 5V and ground pin to the curiosity board using jumper wires. The RL1 input connects to the RC5 output pin. Now connect the negative input for the LED to the power supply's negative output. Connect both the positive input of the LED and positive output of the power supply to relay 1 on the clickboard. Now let's power up the curiosity board and turn on the power supply. You can now wave your hand in front of the motion detector and the LED should light up. Congratulations! You have successfully built a high-power LED motion light without writing any code, using core-independent peripherals on our latest PIC microcontrollers. To find out more about core-independent peripherals, please visit microchip.com/CIP. You can also send us your valuable feedback regarding this project to microchip.minutes@microchip.com. Thank you for watching, and I'll see you next time.